this video, we are going to learn the curvature. The curvature of a polar curve is given by the formula k is equal to p squared plus 2 times the first derivatives of p squared minus p times to the second derivatives of p over p squared plus first derivatives of p squared to the power of 3 over 2. Okay, so let's move on with our example number 1. So our example number 1, we have let p is equal to 2 plus sine theta. And then find the curvature at the point P. So we have this formula. Wait, guys. So we have this formula. Then we have k is equal to 2 plus sine theta squared. So let substitute those value of p. So we have 2 plus sine theta squared times plus 2 times the first derivatives of p. So the derivatives of 2 plus sine theta is cosine theta squared minus the value of p. So 2 plus sine theta times the second derivatives of p, we have negative sine theta. So the first derivative of sine theta is cosine theta. Then the derivatives of cosine theta is negative sine theta, which is our second derivatives. Over 2 plus copy the value of p, 2 plus sine theta squared plus the first derivatives of the given or the value of p, we have cosine theta squared to the power of 3 over 2. Next. So in this term, the 2 plus sine theta squared, we use the we apply the perfect square formula to expand this 2 plus sine theta squared. So the perfect square formula, we have a plus b squared is equal to a squared plus 2 times ab plus b squared. So our a is 2, then our b is sine theta. So a squared is 2 to the power of 2, which is our a squared plus 2 times ab, which is 2 sine theta plus sine theta squared. So or b squared. So our final answer in this of the 2 plus sine theta squared is 4 plus sine theta and 4 plus sine theta plus sine squared theta. Okay, so that's why we have 4 plus 4 sine theta plus sine squared theta plus 2 times cosine squared theta. So in this cosine theta squared is, we have cosine squared theta plus 2. This is positive because the negative times negative is positive. So our sine theta became positive. So 2 plus sine theta times sine theta over 4 plus 4 sine theta plus sine squared theta plus cosine squared theta, the power of 3 over 2. Okay, so in this term, we simplify this inside the parentheses, this one. So we have 4 plus 4 sine theta plus sine squared theta plus 2 times cosine squared theta is equal to 2 cosine squared theta plus sine squared. So this is, we use the distributive property. So we have 2 times sine theta is 2 times sine theta, or sine theta times sine theta is sine squared, over 4 plus 4 sine theta plus 1. This is, in this term, we use the Pythagorean identities, which is sine squared theta plus cosine squared theta is equal to 1. That's why in this denominator, we just have 1 here, because the Pythagorean identities of sine squared theta plus cosine squared theta is equal to 1. Okay, so 4 plus sine theta plus 2 sine theta plus 2 sine squared theta plus 2 cosine squared theta. So the result of this is we have 4 plus 6 sine theta plus 2 plus 2 sine squared theta plus cosine squared theta over 5 plus 4 sine theta to the power of 3 over 2. So we apply the trigonometric identities or the Pythagorean identities, which is 2 plus which is sine squared theta plus cosine squared theta is equal to 1. So this is 2 times 1 is equal to 2, and 4 plus 2 is equal to 6. So we just have 6 sine theta plus 6, and over 5 plus 4 sine theta to the power of 3 over 2, or the final answer is 6 times sine theta plus 1 over 5 plus 4 sine theta 3 over 2. So that's all for this example. And next example, we have find the curvature of P is equal to Euler to the power of theta at P comma theta. So okay, this is our first. This is our formula. So let's begin. So let's substitute the value of P. So A is to the power of theta, Euler to the power of theta squared, plus 2 times a to the power of theta squared minus a to the power of theta times a to the power of theta. So the first derivatives of a to the power of theta is a to the power of theta, and the second derivatives of a to the power of theta is also a to the power of theta. So this is the second derivatives, but this is p squared, and the second derivatives is always a to the power of theta. Okay, so next. So we have a to the power of theta squared is a to the power of 2 times theta plus 2 times a to the power of theta is 2 a to the power of 2 theta, because a to the power of theta is 2 a to the power of 2 times theta minus a to the power of theta times a to the power of theta over a to the power of 2 theta plus a to the power of 2 theta to the power of 3 over 2 a to the power of 2 theta. So in this this is 2 this is a to the power of 2 theta. Then we subtract the a to the power of theta. This will become, or this is 0. So we have 2 times to the power of 2a to the power of 2 theta here. Then the denominator is a to the power of 2 theta plus a to the power of 2 theta to the power of 3 over 2. And it is equal to 2a to the power of 2 theta over 2a to the power of, so this is a to the power of 2 theta plus a to the power of 2 theta is 2 times a to the power of 2 theta to the power of 3 over 2. So we apply the exponent rule. In this term we apply the exponent rule. So the exponent rule, we have x to the power of a over x to the power of v is equal to 1 x to the power of b minus a. So this is 1 over 2 to the power 2a to the power of 2 theta 3 over 2 minus 1 is 1 half. So the power of our denominator is 1 half. Or the key is equal to 1 over 2 to the power of 1 half a to the power of, or it is equal to 1 over square root of 2 a to the power of theta. So that's all for our example in the curvature of a polar curve. So let's have the activity. So the activity is find the curvature of p is equal to sine theta at p theta. So that's all for today's video, and good luck.